Here is a nice problem is coming from the Canadian Mathematical Olympiad edition 2004. Here is the following equation. We have xy equals z minus x minus y. The second equation we have xz equals y minus x minus z. The last one we have yz equals x minus y minus z. Okay, so the question we are going to solve this equation in real numbers. Okay, obviously it seems we have a nice symmetry here, since the first, second, third equation are repeating the same pattern. It's more helpful if we identify the equation which is containing the symmetry, because the symmetry here are going just to conclude the other solutions, because we know working on one side of this equation, which means other equations will be the same. Okay, without loss of generality, we assume x is inferior to y and y is inferior to z. Okay, so let's break this one into several cases. The case number one, if y equals z. Okay, so we are going to fix two variables. We are going to give equality to variables to leave other one free. Okay, so I'm going to take this equality and insert it in the last equation, since we have the product yz here. So I get here y squared equals x minus y minus y, which is equals x minus 2y. Okay, the next thing coming up, just bring minus 2y to the left and leave x at the right side. So which means I get here y squared plus 2y equals x. So I'm going to leave this equation as it is. Let's work on the other equation. I'm going to use the first equation. Okay, so replacing y with z, I get here the following. I get xy equals y, because I have replaced z with y, minus x minus y. I get y cancelled out. I will be left with this equation. I have x y equals minus x. Okay, here is an important equation here. So let's bring the same equation up down here by taking y as a common factor. I get here y factor y plus number 2 equals x. So I get two different equations. All of them are written in terms of x. Okay, so here is a thing. So to divide by x, we must have x different than 0 here. Okay, let's break this one into two cases. If x equals 0, we are going to use this equation. If x different than 0, we are going to use this equation, because we are going to divide both sides by x. Okay, so in case number one, if x equals 0, I'm going to use this equation, which means y is multiplied by y plus number 2 equals 0. Okay, this one is going to produce two new solutions. Okay, because we have two possibilities here. Let's break this one into cases as well. So let's put it as a subcase. Subcase number 1, if y equals 0. Okay, if y equals 0, which means y equals z. Remember, we always are working on this value, y equals z. Okay, y equals 0. This one is telling us z equals 0. Okay, let's pick up these two values and insert them into the first equation to find x. So this one is telling us 0 here, because I have replaced y with 0, is multiplied by x is given as 0. So z will be replaced with 0 minus x minus 0. This one is telling us x equals 0. That means I found the pair of the solution. Let's put all the solutions up here. So I get here x equals 0 and y equals 0 and z equals 0. We found a new pair of the solution. Let's move on to the subcase number 2. Subcase number 2, if y different than 0, which means y plus 2 must be equals to 0. Okay, this one. If y different than 0, which means y plus number 2 must be equal to 0. Okay, that's what happened here. By taking this number 2 to the right, I get y equals minus 2. We found y equals minus 2, which means z equals minus 2, because we have equality. Z equals y equals minus 2. If z equals y equals minus 2, remember we are taking x equals 0 as the original one, okay? Which means x equals 0 is the solution, is including these two solutions, because this one is produce these two solutions, okay? Let's take it as a solution. I will have x equals 0 and y equals minus 2 and z equals minus 2. But remember, we have a symmetry, okay? So I'm going to take 3 copies of this one, okay? Which means I get also x equals minus 2 and y equals 0 and z equals minus 2. Another pair of the solution, I get x equals minus 2 but y equals minus 2 with z equals 0, okay? So actually at this time I get 4 pair of the solution, okay? If x equals 0, it gives us all these solutions. What about x if x is different than 0, which means we are going to use this equation. If x not equal to 0, which means different than 0. Now if x is different than 0, x different than 0, which means we are allowed to divide both sides by x, okay? Which means I have y equals minus number 1. Y equals minus number 1. Because I have divided both sides by x, is giving us y equals minus 1. I'm going to take this advantage of this solution. Remember, also we have y equals z. We're still working on this case, okay? This one is telling us y equals z equals minus number 1. So since both values is giving us the same value minus number 1, I'm simply going to insert this one into the last equation to find x, okay? So I get here y is multiplied by z, minus number 1 is multiplied by minus number 1 equals x minus with minus plus number 1 plus number 1, okay? So actually this one is giving us number 1 equals x plus number 2. This one is telling us x by cancelling out number 1 from left and right, I get x equals minus number 1, okay? X equals minus number 1, so which means I have a new pair of the solution here. So let's add this one here. I get x equals minus number 1 and y equals minus number 1 and z equals minus number 1. Recently we found 5 pair of the solution, okay? Now this is all happening if y equals z. What about if y different than z, okay? If y different than z, we are going to take this inequality, leave it straight inequality. So we are going to use this fact, y is strictly inferior than z. So let's clean up this board and move on to the step. So previously in the last board we were working on the value when we have y equals z, okay? Now in this case we are working if y is strictly inferior than z. So first of all I'm going to use this equation and this equation. So at this point we are simply going to sum the two first equations. Let's put this one plus this one. If I'm going to do that, I will take x as a common factor for the left hand side of this equation. I get x factor y plus z. For the right hand side of this equation, by summing this one, I get y eliminated because we have one is plus, the other one is minus, and also z will be eliminated. I will be left only with minus 2x. Minus 2x. Remember, we are taking the strict inequality. So x equals 0, we already found those solutions. Now in the case if x is strictly superior than 0, with x strictly superior than 0, I'm going to divide both sides by x. I get here y plus z equals minus 2. Okay. Now this argument follows similarly to other equations. So I will find another two equations. It will be written on this form, y plus, it will be written on the same form, y plus x plus y equals minus 2, and x plus z equals minus 2. So I will do the same kind of what I did here. I'm going to do the same job that I have done here. Then you will find the second equation and third equation. You will find three equations are equal to each other. Okay, so remember here always y strictly superior than 0 and z strictly superior than 0, because you are going to divide both sides by y and z, so in order to have these equations. Okay, and now we are going to use this one, y. So we have y is strictly inferior than z, which means I get y minus z is strictly inferior than 0. This one implies y minus z is inferior equal to minus number 1. Okay, we want to zoom this one in by including minus 1. We are going to put this one on this form. So let's call this one equation number 1, number 2, number 3. Let's stick to minus 3. Okay, so I get x eliminated. I get y minus z equals minus 2 plus 2, which is 0. Okay, let's replace this one with 0. Let's stick this one here. I get 0 is inferior equal to minus number 1. Okay, this one is impossible. Okay, so which means you have no solutions when you have y is strictly inferior than z. The only solution that we found when you have y equals z. Okay, regardless of the symmetry. So this argument follows similarly for x and y. Okay, so I have ended this video. By the way, don't forget to hit the subscribe button and support the channel, and thank you for watching. I will see you in next video. Bye.